This is our Precalculus mid-second 6 weeks test, part 2 for this fall semester, and it's just 12 problems, so it should be pretty quick. For the function fx equals a quantity x minus 3 squared minus 10, which equation represents its axis of symmetry? And what we have here is equation for axis of symmetry. We have axis symmetry is formula x equals h. Well, you might ask what h is. The vertex form of the quadratic equation is this: a times quantity x minus h squared plus k. So this value of h is what makes this thing move left or right. And so in this instance we have quantity x minus 3 squared minus 10. So the h, the 3, takes the place of the h in this form of vertex equation. So that means that h is equal to 3. And since h equals 3, our axis symmetry formula is x equals 3. So that is our answer. Answer choice B. Next problem. For the function y equals x squared minus 4x plus 6, which equation represents the same function in vertex form? Well, there are a lot of ways to do this one. One way is we can break this equation, x squared minus 4x plus 6, and write that equation as a perfect square. To do that, well, if we have x squared minus 4x, what we have to add to make a perfect square to 4x is you take half of this coefficient, which is negative 4, divided by 2, which equals negative 2. And if we square that, negative 2 squared, we get 4. So if we add 4, we have a perfect square right here, plus you have this 2 extra outside the parentheses. So we can rewrite this quantity x squared minus 4x plus 4 as x minus 2 times x minus 2 plus 2, which is equal to quantity x minus 2 squared plus 2, which is our answer choice. That's 2. That's our answer choice D. Another thing you can do is you can multiply this out, this answer choice D. You can try this one at a time if you have time for that. So if we have x minus 2, this is working backwards from the answers here, plus 2, we can go like this. I'm sure you've seen that FOIL thing, or you've seen some kind of a box method type deal. Okay, where you got x minus 2, x minus 2, multiplying all that out, adding together. Should be a pretty easy problem. Graph, you can graph this first function here, y equals x squared minus 4x plus 6, and see which graphed function in vertex form matches y equals the original function. So not a very good excuse for missing that one. Okay, problem 3. The axial symmetry formula is what really helps with this one, which you need to know. And this stems from the quadratic formula. You have x equals negative b plus or minus the square root of e squared minus 4ac, and that's going to be over 2a. Let me write the 2a over to the left. 4ac over, I'm going to put the 2a over to the left here. And this part here that I'm boxing in a line is the axial symmetry formula. So that's going to be x equals negative b over 2a. Well, in this situation up here, we have a is equal to 3. We have b is equal to negative 12. And c, which we don't need for the axial symmetry formula, is 8. And so we have x equals negative b over 2a. So we're going to plug in negative 12 for the b and 3 for the a. And so that's going to take you right to answer choice C. Another thing you could do is put this in, create this in Vertex form. That'd be too much work. Find another thing you could calculate what that is, and you can use the calculator to graph it, see where that axis symmetry is, and see which one of these answer choices matches that potentially. A lot of different ways to do this. How many real zeros are found in the function fx equals x squared minus 6x plus 12? Again, different ways to do this. We can get a perfect square and see what happens to this. I'm just going to graph this function. We have x squared, graph page in TI Inspire CX calculator, minus 6x, and it's going to be plus 12. And here we are. We have no real solutions. There are no x-intercepts or zeros here, or real zeros. So we go to our answer choice and we say the correct answer is A, 0. Should be pretty easy. Find the solutions of the equation shown below. Well, what you have here is we can take advantage of something called the zero factor property of algebra. And zero factor property is quite simple. Sounds a lot more advanced than it is. Zero factor property, anything times 0 equals 0. So if x equals 0, that's a solution to the equation. If x minus 3 is equal to 0 and therefore x is equal to 3, we know that's a solution. And then lastly, if we have x plus 5 equals 0 and we solve for x is going to be equal to negative 5. So negative 5, 0, and 3 are what we're looking for. Answer choice C. Sometimes if you just look at this and you're a little lazy, you might be tempted to pick negative 3, then 0, then 5, or just negative 3 and 5. So anyway, that still should be quite easy. Find the binomial factors of the following quadratic trinomial expression. We have 3x squared plus 7x minus 6, and then you have these different options below. Well, first of all, you have minus 6. So how do you get to a negative? By multiplying a negative times a positive. So anything like answer choice A and answer choice B, off limits immediately. And then you can just multiply choices C and D together if you'd like to see which one gives you this middle term of positive 7x. I think it's answer choice D. You can factor and go straight to the answer as if you didn't even have an answer choice. And you can say 3x squared here and negative 6 here. Factors of 3x squared would be 3x and x. And factors negative 6 are going to be negative 3 and 2. So, or negative 2 and 3. So we'll put here negative 2 and 3. So we get 3 times 3x, which is 9x, and negative 2 times x, which is minus 2x. And so we have this situation right here, answer choice D. Next problem, 7. Which parent function below, when transformed, would best model the data in the table below? Well, for this, you can use your calculator. I'm going to go get a add list and spreadsheets. Go here and put in x, and I'm going to put in the x coordinates here for the table. I have 0.043. Next one is 0.16. Then 0.38. I'm rounding pretty severely here. 0.59. 0.89. And the last one in the column here was 1.26. Then coming over here, go to the other column, put y up here. We have output value of 0.82. Next one is 1.7. 71. Then we have 2.46. We have 3.05. We have 3.74. And then we have 4.5 rounded. So we have x and y values match the same. So if we go to Control I and go to Add Data and Statistics, option 5, we get these points kind of randomly strewn. If we go to Tab, we can pick our x value along the independent variable axis and press Tab again, and we can get the y along the dependent variable axis. And we have this kind of looking thing. All right, so if you look at the different possible options for answer choices, you see what this looks like. It could be linear possibly, but there's something better probably. So you go to our answer choices, and the parent function for a square root function, which is answer choice C, looks something like this, which best matches, it looks like, our data. So we'll say C is our correct answer for 7. 8. Which of the following 4 graph polynomial functions might have an odd degree? So these are not very pretty polynomial functions, but to be odd degree function, you have to start low and end high, or start high and end low. And if you look at answer choice A, you're starting low and ending low. C, you're starting high and ending high. And D, you're starting high and ending high. It's the only place where you actually have to cross the x-axis for sure is to start, in this case B, start high and end low, which is going to be a negative odd degree function. So anyway, 9, related to number 8, pretty much, for the function graph below, describe the nature of its degree as even or odd, whether the function is negative or positive, and its end behavior. Well, we should recognize this type of function is odd because we're starting high and ending low. Where the function is negative, well, we're starting high and ending low, so we are negative. And its end behavior is going to be the limit as x goes bigger toward infinity of f of x, we'll call the function f of x, is going to go toward negative infinity. So these are the three things that we're looking for. And they manifest themselves here in answer choice C. Next, 10. For the graph of the function pictured below over which approximate interval is increasing in value, well, we're decreasing all the way to this thing here where x equals about -3, and then increasing all the way up to about x equals 2. So the best answer for this is going to be answer choice B. Next, 10. What is the degree of the polynomial function below? Mark your answer in the grid provided. Well, what you look for is the term with the highest power exponent in a polynomial function. So it's going to be this -6x cubed. And this is going to be of a degree equals 3 because the power. So if you just mark 3 here, and you can put a +3, but it really doesn't matter, and then just mark in your grid here, you're going to be able to get full credit for this. Again, the plus sign, not necessary. Plus is already assumed. Next one, for the function g of x equals x cubed minus 5x squared plus 2x plus 8, what is the value of one of its zeros? Mark your answer using grid provided. This is a problem that has more than one correct answer. So I'm going to show you what that looks like here. We got x cubed. And we could solve this by factoring. It would take a little while, maybe a little synthetic division, but calculator in hand, it should be real easy work. So we graph this. We have a 0 at x equals -1, and at 2, and at 4. So we will say x equals -2, 1, 4. So any of these answers here would suffice. And we'll just say, I get that right? No, it's 2. This transcription here, let's go ahead and do that. It's -1, 2, and 4. I've got my own problem on. So -1, 2, and 4. There we go. So you can just put any of these. If we put in 2 here, which I saw a lot of people do, there we go. That's one possible right answer. Or -1 or 4. Any one of these three answers would be correct. Well, good luck. Good studying. Hope you did great on this. Thanks for viewing.